In Units 1 and 2, we focus exclusively on operational databases, and the databases that we use for SQL queries were operational in nature. When we say operational, we mean that the purpose of the database was to support core business processes. Consider the Home Away from Home database. Home Away from Home was used to catalog apartments, tenants, staff, and inspections for a real estate company. In other words, the database is focused on supporting the core business needs that exist right now. These current and core business needs lead to operational questions. Home Away from Home needs to know who is currently renting their apartments, who manages the buildings, and who's assigned to clean each apartment, among other things. But there are other questions that aren't supporting our current and core business needs that are important to decision-making processes. Home Away from Home might want to know which tenants pay their rent on time consistently, or which building managers are most successful in passing inspections. These questions are important, but they're not crucial to the immediate needs of the business. They're analytical questions, or questions which support decisions and require analyses, but don't directly support operations. Operational and analytical questions are different in a number of ways, and they require different compositions of data, have different functional uses and technical needs. Let's discuss each of these now in detail. There are three key categories where operational and analytical data differ: the composition of the data, the function of the data, and finally the technical requirements for each. First, let's discuss the function of the data themselves. The key difference is who uses the data, or what we call the audience. The audience for operational data are typically the line workers and operations managers, people who are performing the core functions of the firm. Target's line workers would be floor workers, cashiers, stockers, and merchandising workers. Notably, this doesn't mean that everyone using an operational database is writing SQL. For example, floor workers at Target will frequently query the operational database with handheld devices, and cashiers will interact with the operational database by operating the register. In both of these cases, the database is being operated indirectly with an application translating actions into SQL commands. These are examples of application-oriented use, where the database is being used to support one specific task or application. These application-oriented uses by line workers are typical of operational databases. Analytical databases, on the other hand, tend to be used by analysts and decision makers in a subject-oriented manner, or questions which span a business subject area, such as inventory or sales generally. Because of these differences, the composition of data will differ. Since an operational database is being used to support current operations, this implies that what happened in the past is not of real value. If a Target shopper asks a floor worker if there's soup in the stockroom, the amount of soup that was in stock 2 months ago isn't going to help in answering that question. An analyst at the home office, however, might be concerned with trends in soup sales, and those data would be important. As such, while operational data is typically a snapshot of the current state of business, analytical data is going to be concerned with historical trends and changes in the data over time. Similarly, the level of detail is going to be different. The individual stock of specific SKUs are of concern to operations, but in analyses, a zoomed out perspective is going to be valuable, at the category level, for example. Because of these differences, there are different technical needs for each type of data. Operational data changes quickly. Consider how many people are checking out at Target across all U.S. locations on any typical day at 6 p.m. There are going to be thousands of updates made to sales and inventory databases every second. Analytical data is less concerned with being up to the minute current, and is as such typically updated once a day during off-peak hours, such as in the middle of the night. Operational data is also much more sensitive to time delays. If an operational database is overwhelmed and it takes a long time to ring up customers, that's going to be a large problem. If an analytical database is overwhelmed, an analyst is going to be inconvenienced, but that's less likely to be a show-stopping issue. Because of the differences in questions and the data that support them, we typically use database systems which are designed purposefully for analytical use. Generally speaking, we call these systems data warehouses. We define a data warehouse as a structured repository of integrated, subject-oriented, enterprise-wide, historical, and time-variant data. Let's take these one by one. A structured repository is a fancy way of saying it's a database. Ultimately, a data warehouse is a database in all the ways that are important. The rest of the definition gets into the differences. The integrated aspect delineates one key difference between a data warehouse and an operational database. An operational database at Target is concerned with what's going on at Target, But an analytical database is likely to include other data that have nothing to do with the day-to-day operations, such as the weather, the season, or if there's a pandemic shutting down large swaths of the retail sector. Data warehouses will often include these data since they may enhance analyses. Subject-oriented differentiates between the application-oriented orientation of an operational database. A data warehouse is looking to collect data about all the sales over some period of time, and an operational database is concerned with what Carol is purchasing on checkout lane 3. Enterprise-wide refers to the wide net that a data warehouse is intended to capture. Notably, all relevant data about subject areas should be captured in the same data warehouse. Historical and time variant are related. The historical aspect emphasizes the fact that the data warehouse should include data from the past as well as the present, in contrast to the operational database's emphasis on the present. Time variant highlights snapshots, that we want to see the changes in individual metrics over time. In contrast to an operational database, a data warehouse is going to draw data from a number of different components, called source systems. These source systems will include operational databases themselves, as well as external systems or data such as economic, meteorological, or population data, among others, depending on what's most useful. These source systems are loaded into the data warehouse using a function called extract, transform, and load, or ETL, which describes the process used to populate the data warehouse. These ETL processes are typically run on a set schedule, and usually during downtime, such as in the middle of the night. ETL, unsurprisingly, includes 3 functions. Extraction involves taking data from analytically useful sources, such as operational databases. Transformation manipulates the data in such a way that the orientation of the data is focused more on analytically useful rather than operational useful metrics, such as looking at sales per hour rather than sales per transaction. And loading involves inserting the observations into the warehouse. Front-end applications for data warehouses exist in the same way that they do for operational databases, although they do tend to be less customized. These are typically referred to as business intelligence applications, or BI. Modern data warehouses frequently have BI applications built into the system itself. Finally, there are subcomponents of data warehouses which tend to be focused on the needs of an individual, referred to as data marts. A data mart is conceptually very similar to a data warehouse, but is often limited to select subject areas as to focus the attention of the user or to protect confidential information. Now that we've discussed the differences between data warehouses and operational databases, the modeling of these systems is also going to be different. So we'll discuss these next time in Chapter 8.